Everybody stand for opening prayer. Okay, good morning, class.
Good morning, Ma'am.
Alright, please have a seat. And who's absent for today?
Nan po.
Okay, so before we proceed to our new lesson, who among you remembers our previous lesson?
The previous lesson is about weather disturbance po, Ma'am.
Okay, very good. So our previous lesson was all about weather disturbances. And what was weather disturbances all about?
It is a term used to a change in atmosphere conditions or weather patterns, a temperature disturbance between the air and the surface creating a swirling mass of winds.
Okay, very good. That shows that you really understand our previous lesson. Now, we may proceed to our discussion. Okay, class, I'm going to discuss energy transformation. So, can someone please read what is energy? Okay, Alvi.
What is energy? The stuff that makes stuff to do stuff. The ability to do work.
Okay, thank you. So, energy is the capacity for doing work, and it is the strength required for sustained physical or mental activity. So, class, how do we identify energy transformation taking place around us? But before that, what is energy transformation? So, energy transformation is the damage from one person to another. And the most common energy conversions involves the changing of potential energy to kinetic energy or vice versa. So later, I'm going to discuss potential energy and kinetic energy. But before that, can someone please read what is law of conversion of energy? Yes, Alvi.
Energy cannot be created or destroyed, but it transformed from one form to another.
Okay, thank you. So like for example is lighting a match. So chemical energy transforming into radiant or light and thermal or heat. So what is potential and kinetic energy? Can someone please read? Alvi.
Kinetic energy. Energy from motion. The faster an object is, the higher the kinetic energy. Potential energy. It is a stored energy that depends upon the relative position of various parts of a system.
Okay, thank you. So potential energy is the stored energy that depends upon the relative position of various parts of a system. So like for example is a book on a desk at the top of the mountain or a water from the top of the falls. So, and kinetic energy is the energy from motion. So, or the motion of an object. An example for this is a person riding a bicycle. So, Alvi, will you give an example of potential and kinetic energy?
An example of potential energy is a book above the table because the object is at rest. And an example of kinetic energy is a person riding a bicycle because the object is showing a motion.
Okay, very good. So, can someone please read what is mechanical energy? Alvi?
Mechanical energy, energy of motion or position, not 100% efficient, much loss to heat, sound, wind, waterfall, compressed spring, moving machine parts.
So, mechanical is the energy of motion or position. Like, for example, is the wind, sound, waterfall, compressed spring, and moving parts. And next is
Heat.
heat or thermal energy. Yan. So, for the heat energy, Albi, can you read?
Heat or thermal energy, the internal motion of an object's atoms and molecules. Measured by temperature, the fastest particles move, the more thermal energy they have.
So, heat energy. For the heat energy, it is measured by temperature. An example for this are the sun, electrical appliances, burning wood, eating food, and friction. So, for chemical energy, Albi.
Chemical energy. Energy stored by chemical bonds in an object. When bonds are broken, energy is released.
So, for chemical, it is the stored energy in the bonds of atoms and molecules. An example for this are batteries, biomass, petroleum, natural gas, and coal. So, for nuclear energy, LV. Can you read?
Nuclear energy. Energy stored in center, nucleus of an atom. Most powerful, potential energy only.
So, for nuclear is the most powerful. An example for this is a fission, breaking apart, fission or forming, or the sun. So, for the electrical energy, LV, can you read?
Electrical energy. Moving electrical charges. It is related to forces on electrically charged particles. This energy is supplied by the combination of current and electric potential that is delivered by a circuit.
So, electrical is the movement of electrons from one point to another. And an example for this is lightning and electrical charges moving through a wire plugged into the wall, socket to power. Electrical appliances such as televisions and computers. And lastly, electromagnetic energy. Albi, can you read?
Electromagnetic energy. Electromagnetic or radiant energy. Energy that travels in waves have electrical and magnetic properties.
So, electromagnetic is the radiant energy that travels in waves at the speed of light. Like for example is radio broadcasting, Wi-Fi, cooking, vision, medical imaging, and treating cancer. So what are the 6 forms again, Alvi?
The 6 forms of energy are mechanical energy, heat or thermal energy, chemical, electromagnetic, heat or thermal, chemical, electromagnetic, and nuclear energy po, ma'am.
Okay, very good. So class, how can you show that energy can be changed from one form to another? Okay, Alvi.
Energy can be transferred by doing work and by heat transfer po, ma'am.
Okay, very good. So justify your answer.
So, energy can change from one form to another. Like for example, when you switch on a light bulb, electrical energy changes to thermal energy and light energy.
Okay, very good. So energy can be transferred from one form to another by heat transfer, and whenever energy changes, the total amount remain constant. So did you understand our discussion for today?
Yes po.
Okay, that's all for today. I hope you learned something from me. Thank you.
Thank you po, ma'am.